So, so this first cell is pretty much just first introducing Jupyter, kind of the uses and everything. So, um, if you don't know already, Jupyter is really useful for kind of segmenting up your ideas into cells, which are kind of these segments here. If you look at this blue line, it starts up here and ends down here. So this is what my first cell is. This is the second cell, third cell, and so on. And then what you see here, if you look up here, you see Markdown. That's where you can do all your text, kind of just type out ideas. And then if I click here, I have code. So depending on what kernel you're using, I'm using Python 3. You should be as well. And if you click down, you have a bunch of different things. I usually just use code and Markdown. You don't need much else. So, okay, you have Markdown and you want to access the cell. All you do is just double click it. And so you have hashtags that's for titles, and your title can get smaller the more kind of you introduce. I think it caps out at 6, I believe, yeah, 6. And so if you want to do like headers and kind of subheaders and all that stuff, it's nice for formatting. Dashes are really useful for for listing things out. As you see here, dashes are super helpful. And it's also really useful for LaTeX, which is how you can get these sort of mathematical equations. If you don't know how to use them, you don't have to worry about it. But it's very useful for like writing out academic papers and stuff like that. And it makes just things look pretty, like any formulas you have. If you see these 3, I really don't know what those are called. It's the key. It's not the apostrophe, but it's next. It shares the key with the squiggly. I'm not too sure what it is, what it's called exactly. But if you put something between it, so F, for example, that will kind of put it in this little gray box here. And that's really useful for like giving directions or typing in code that you don't want to run, but you just want to give like example code for, just within the text. So.
Oh, is it like the tilde? Like those 3 like almost quotation marks before the A or whatever?
Yeah, I'm not too sure what it's called, but yeah, it's for me, I have a Windows that is like, it's with the squiggly or the tilde, and it's next to the 1 key for me.
Oh, yeah, okay.
I'm not too sure where it is for Macs, but yeah, you can find it somewhere on your keyboard. So if you have your cursor, or if you have kind of your little icon within the cell, then you're inside the cell and you can make edits. So, you know, I want to get rid of this. Cool. And then I want to undo Control Z. Now, if you're inside the cell and you hit escape, you see that I no longer have my little cursor here. And let me do it again. You see it goes from green, which means you're inside the cell, and then you hit escape and it changes to blue. So what that means is that now you're outside of the cell and you hit escape. So you can think of it as escaping the cell. So now that you've escaped the cell, you can go between cells. And then if you want to go inside a cell, you enter it. So you hit enter, and now you're back in the cell. So I'm going to escape. And now this is really useful if you're making, you know, quick edits and stuff. Okay, right now I'm inside the cell and I want to run this. So I pretty much want to see the text. You can hit run, or you can just hit shift enter and it'll run everything for you. And that goes the same with code, which you'll see soon. And so it's blue. So now I'm outside the cell. I put a few little things here that I use a lot. If it's blue, you're outside the cell and you hit A, think of that as I'm creating a new cell above this cell, and here we go. So now I'm here, And then let's say I want to create a new cell below. I'll hit B. So now I created one above, which I'll remove right now, and below. And then let's say I want to copy it. You can think of it like Control C is copy if you're dealing with text, Control V is paste, and Control X is cut. So that kind of plays into Jupyter as well, but without the control. So again, making sure you're blue. If I hit C, I copied it, and then now I paste it. So I hit V, and now I have two of them. Okay. And then X is for cut, but I like to use it for delete a lot. It's pretty easy because I generally don't copy and paste too many cells. So using X as delete. Make sure Jessica gets in the room. Okay, great. So yeah, I use X a lot for delete, making sure that it is, like I said, I don't copy or paste too many cells. So X can be used for cut, but I like to use it for delete. I'm pretty sure there is, pretty sure if I hit delete, no, that doesn't work. I'm pretty sure there is a shortcut to delete cells, but I'm not too sure of it specifically. And like I said here, if you want to find all the shortcuts, all you have to do is go to help and then keyboard shortcuts, and then you'll be given pretty much everything here. And so you can open the cell by double clicking it, and then you can mess around here. You can list things here. So generally it is best if you space them out between a line. So item 1, and if it's in blue, then you're looking good. Item 2, item 3, and then shift enter to run the cell, and then I have my little list, okay? So that's just the basics of using Markdown and just kind of going between cells for Jupyter. And so do you guys have any questions? Okay, cool. So we'll jump into learning about Pandas. So Pandas is a Python package that is really useful for looking at data, observing data, if you want to manipulate it, shorten it, expand it, so on. If you've ever used Excel spreadsheets, then you know how to use Pandas. Like it really is that simple. So we'll first start whenever you want to import a package. So Pandas is a package that has a bunch of different classes and functions and everything. All you do is just type in import pandas as PD. The as PD is just kind of shorthand notation. So instead of having to constantly type out pandas, 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 you can just type out PD. It's very common in Python to do this. So I would recommend keeping that going. So shift enter, you run the cell. And as you can see, there's no output, that's good. But it did run, as you see, input 1. It ran, no errors. So now we have Pandas loaded into Python now. So I'm going to give a quick introduction to dictionaries and lists. So I'm going to call this variable dictionary, and then you call it by essentially using these squiggly brackets. And what a dictionary is really useful for is having what's called keys and values. So if I type in key here, and then parentheses 3, and then I can kind of list out a few different things. So I'll say key 2, and then that'll be 5, and key 3, and that'll be 8. Now, shift enter. I have my dictionary. Now I'm going to re-enter the cell. And now what you can think of it as, you can think of these keys as actual keys to a lock. And when you put in the proper key and unlock it, you open your door and you get a value. So if I type in key, if I use that key, I'll be returned 3. If I use the second key, key 2, I'll get 5. And if I use the third key, key 3, I get 8. So how you unlock it technically is you'll call the variable dictionary, and then you'll put in a square brackets, and then you'll type in which one you want. So let's say I want to use 5. What I'll do is I'll type in key 2, and then if I run it, as you can see, it returns 5. And so you'll see why this is pretty useful in a second. And then list 1. And now I want to also introduce lists as well. You use square brackets as well. And you can think of this as a vector, essentially. It's not, Python doesn't look at it as a list, as a vector. We'll look more at vectors when we work with Numpy and everything, but it's technically the same thing. So, or you can just think of it as a list of things. So if I want a list of numbers, 7, 4, 3, 3. Okay, I run it and I return list 1. Now I have this little list. So this can store however many values I want. And so now the reason why I'm introducing this is that Pandas can create data frames or spreadsheets using dictionaries and lists. So how you can do that is that if you look at your key as your column name, so let's say I have 3 different columns and I have 4 values for each column, I can put that here. So I think this will make more sense in a second. So df, I'll create a variable called df that will stand for data frame, and I'll create my data frame by saying pd dot data frame, capital D, capital F, and then now I call this method, and now I'll input a dictionary. So here's what I'll do beforehand. I'll call this data frame dictionary, and I'll create a dictionary. So let's see. So let's say you want to look at different, different laptops, for example. You can have different brands, different sizes, and different prices. So I'll only work with numerical values. So my first column, for example, will be size of laptop. And I'm going to have it, let's say I'm only looking at 3 laptops. So the first one, it'll be the size, let's say size of screen. Okay. And let's say the first one is 10.5 inches. The second one will be, let's say 12 inches, and the second one is 15 inches, or the third one is 15. And then I can also do price. And let's say this is $200, this is $300, and this is $500. Now, since I created this dictionary, I can put this into my data frame. And then if I return the data frame, you'll see that your key is just the column name, and the list you put in becomes your column. So it becomes the values of that column. Now, and so let's say, now I created this data frame, and let's say you didn't set this up, okay? So let's say you didn't have this, but you still, and you were just given this data frame. So let's say we don't have these. What I did there is Control/ will comment things out. So let me work in a new cell. So let's say you were just given this data frame. You didn't really set anything up. You were just given this. Now I only want to look at the size of the screen, or I only want to look at the price, and I want to isolate these columns. So what I can do is call it the same way I would call a dictionary. So here in this dictionary, if I called key 2, I would be given 5. Here, the same thing applies. So if I call the price, then I'm given the index and the price. So the first laptop is 200, the second is 300, and the third is 500. Okay. Any questions so far? Okay. Now you can also import data as well. Now, like I said, I gave you this avocado spreadsheet. So I'll just call this avocado equals PD dot. Now we'll call pandas, but rather than calling data frame, we'll tell it to essentially read the CSV file. So read underscore. Now, if you have this, actually, I'm just going to type in R. I'm going to type in R, and I want you guys to hit tab and give it a second, and you'll be given all the functions that start with R that you can use. So this is really useful if you forgot the function specifically, because let's say I didn't even type in a letter. I just did PD dot, and then I hit tab. Again, give it a second. I'll be given all the functions that I can use if I call the pandas package. So read, and as you see, it short lists as you type things in. So read CSV, and then now the name of the CSV is avocado.csv, as you see here. However, if you hit tab, you'll be given this. Forget that. What you'll do first is type in strings. So you'll type in quotes first, and then you hit tab. And this should return, this has a bunch of weird things. So I'll just type in avo and then hit tab, and then you'll be given, it'll shortlist things for you. And the more you type in, so let's say so yeah, the more you type in, especially if it's from a file or folder, the more you type in, the quicker it'll predict things for you. So let's read this. And now we see that it has the index here, which is kind of weird, but we don't need to worry about that right now. We have the date, average price, total volume. This kind of came with the data. Again, I'm not too sure what this was. And we have the total bags of avocados sold, small bags, large bags, extra large, the type of avocados, the years they were sold, and the region that they came from. So when you read it, there are a few parameters that you can put in to make this look a bit cleaner. So what you can do, and let's say you don't know everything off the top of your head, Jupyter is really useful in that if you hit, now I'm within the parentheses, and you hit Shift Tab, now it will give you the documentation of Pandas read CSV. So if I hit that little arrow button, I'm given everything that I can and I'm allowed to use. So this is really useful if you want to kind of clean things up, especially if you want to just be able to open up your CSV and have it as clean as possible just from the get-go. Now, there will be some that I'm using. So what I'm going to use is, let's see. I will use date parser because we have the dates here. Parse dates as well, or no, just date parser. Actually, we don't even need that. It should do it automatically. When I was testing this, it did do it automatically. But I will use index column simply because this is a time series. So I want the date to be the index. So here's what I'll do. I'll set index column equal to date, or I can, this is the first column, this is the second column. Now, since we're in Python, indexing starts from 0, as you can see here. So the second column is really number 1. So if I type in 1 and then hit enter, you see that the date now becomes the index. Now, this isn't in order. As you can see, it goes from December 27th, December 20th, 13th, and so on. We can order that really easily. So if you type in index, avocado.index, it'll give you all the indexes, and as you can see, December 27th, December 20th, and so on. Now I can set this equal to, and I use the function sorted avocado.index, and then I return avocado again. So what sorted does is, as the name implies, it will take whatever you give it, which is the index, which are all the dates, and it will sort things out for you. So now, as you can see, it sorts all these, and it does the same thing here as well.
Yo, that's pretty useful.
Yeah, very useful.
Wait, where'd you get the data set from?
Kaggle.
Okay. And then, like, is this from like a farm or something, or like a store that sells avocados, or?
I'm not too sure where they got it from. I didn't look at that specifically, but I think it just looked at different regions, either where, like, different regions of farms will probably be my guess, like where the avocados came from.
And wait, was everybody else able to load the data set?
Yeah, I was able to load it.
For sure.
Are you having difficulties with something?
Adi, you good? Or
Yeah, I'm good. I was muted.
all right.
Yeah, Vishnu, did you need help with something?
Oh no, I'm chilling.
Okay, cool. So we already talked about selecting certain columns, but we'll do it again. So let's say I want avocado, and let's say I want to see the total bags sold. Now, again, I can do the same thing. So I can type in total and then hit tab, and then it'll give me total bags or total volume. Cool. I want to see the total bags. And same thing, it'll sort out all the indices for me, or it's already been sorted, sorry, but it'll give me the index and the value with respect to that index. And then let's say I want to clean it up, so I don't know what these are, and I don't want unnamed. Let's say I just want the average price, and I want the type, for example. So I want to see kind of the types of avocados and their average prices. What I can do is, within the square brackets, create a list and say, have it be average price. Now note that there is no space, so you should be pretty careful. You can just copy paste it. And so if you create a list, and that's what I'm going to do here. Now, if I create a list of just average price and type within the square brackets, so it's a list within the square brackets here, and I run it, then I just get that data frame of those two columns. Okay. Any questions? Okay, cool. So now we'll jump over to Numpy. Numpy is really useful because, like I said before, Python recognizes, lists, and you can kind of think of that as a vector. But if you use a list, Python won't look at that as an array or a vector. So Numpy kind of allows us to use matrices, use vectors, do dot products, and a lot of linear algebra stuff. So it makes scientific computing a lot easier, and just kind of does all the heavy work for us. So here we'll import NumPy in the same way that we imported Pandas as PD. It's kind of traditional to import NumPy as NP. So we'll do the same thing here. Now, the first thing, I won't go too deep into this because I doubt that we'll use this unless we have you know, we have data and we explicitly know their distribution, the distribution that the data came from. Otherwise, it's pretty good for like modeling and stuff like that. But you can model random distributions of any size you want. So how you do that is numpy np dot random dot, and then if I hit tab, I'm given all these different distributions: chi-squared, binomial, beta, exponential. And then if you scroll down, you can get multivariate normal, or you can just do normal. So I'll start with a normal distribution. And if I run that, I'll get a random number. And let's hit Shift Tab. Now you see location, scale, and size. Those are 3 parameters that you can put in. Your location parameter is essentially your mean. Your scale is your standard deviation. And your size is how many values you want. So if I want, now what I can do is type in location equals, and then I'll put in a number, scale equals, put in a number, and what was it, size? Yes, size equals, and then some number. But if I do it in order, so what I can do is, let's say I want a mean of 3, a standard deviation of 1, and I want 4 data sets, or 4 data points, sorry. If I do it in order, it should give me 1, 2, 3, 4. So, and also it says array, and we'll see how to actually create arrays and all this stuff in a second. But anytime you work in NumPy, you get data points from it, or you're working within, it's manipulating these data points, you will be working in arrays. So this is a 1-dimensional array, which is just a vector. 2 dimensions is a matrix, and then you can have 3 dimensions, which I mean, when I was taught it, it was called an array. So you can think of it as, you know, if you have a piece of paper and that's a matrix, you can have layers of matrices. So you have a bit of a depth as well. That's your 3rd dimension. And then anything above that is pretty hard to visualize, but you can go essentially as large as your computer can handle. So I'm going to create 100 points. And as you can see, we have 100. And I'll call this my normal, just my normal array. And so, okay, cool. So I'll just leave it there for now. And so let's create arrays now. So we'll call this array 1. And what you do is you call NumPy array. And now what you do is you input a list. Now this is just a vector, so actually I'll call this vector. So this will be 1 dimension. So this will be 3, 4. And then if I call vector, now I'm given an array of 3, 3, 4. Cool. So let's say I want to create a matrix now. I'll do the same thing, array. However, what you should do is essentially create a list of lists. So what does that mean? So let's say I want a 3 by 3 matrix where each row is 3, 3, 4. I'll do 3, 3, 4. 3, 3, 4. And then once again, 3, 3, 4. Now I'm not too sure. I'm going to put it between square brackets, but I'm not too sure if we put it either inside square brackets or you don't need it. So we'll see in a second. Okay, so what you do is you have each row be your list separated by a comma, and you put all your rows into one larger list, and then now you create a matrix. So this is a 3 by 3 matrix. So let's say I want to manipulate this. Ooh, let's make it 32, why not? And then I run it again, same thing. Now you have your vector and you have a matrix, and you can kind of look at your little, you can look at a few different things. So let's say matrix dot, and we hit tab, give it a second. and you should be given a few different things that you can work with. If not, sometimes it does this, it's okay. So if you type in shape, it will essentially give you how many rows and how many columns. So we should expect a 3 by 3, and it will return a tuple, which is 3 by 3. So what do you guys expect if I type in vector? What do you guys expect? What do you guys expect the shape of this to be?
You'll see the shape, like you'll see how many columns and how many rows are there.
Yeah, so if I find the shape, if I want to return the shape of the vector, what numbers do you expect here for this vector?
1 times 3, maybe?
Mm-hmm. So, okay, close. So if there are no columns, because this is just, you can think of this as one row. So you have 3 and no columns. Huh, that's weird. Generally, this is your row. So this is the length of your, oh, okay, this will be the length of your row, and you don't have any columns, so this will be 3 by nothing. If it were a column, so what you could do is, I don't know if you can. So if we do the transpose and then find the shape, it's still the same thing. That's weird. I don't remember the transpose off the top of my head. Let's try matrix. 3, 3. Okay, so it works better with matrices. I guess it doesn't really transpose vectors from the get-go. So as you can see, this, which was your row, is now your column. So 3, 3, 4, 3, 3, 4, 2, 2, 4, 2, 2, and 4, and then 3, 32, and 4, now your last column. So now when it comes to indexing, how we'll index this matrix. So let's see. So matrix transpose, it doesn't really save it. So it doesn't really edit this matrix, as you can see. It kind of becomes its own thing.
It
So,
just performs the operation.
yeah, exactly. So if I wanted to save this, I could do M capital T, let's say, but I don't really need it. So I'll just leave it be. So you have matrix, you have this matrix, and let's say I want the first row and from the first column. So that would be this one, right? So what you do, same way that you kind of indexed, you would index with lists or stuff like that, is you put square brackets after this. And remember that Python's indexing starts at 0. So if I want the first row, okay, so let me take a step back real quick. What I always like to do is I'll put the square brackets and then I'll put a comma. So this comma essentially separates your rows from your columns, okay? So anything before the comma will be your row. Anything after will be the column. So I want the first row from the first column. So remember, indexing starts at 0. So that's our first. So what do you guys expect to be returned from this?
3.
3.
Yeah, perfect. So cool, I have 3. And then let's go back to here. Let me keep this matrix. That way we can see it. And then now let's say I want, again, comma. Now I want, let's say, the second row. So it'd be 1. And I want the third the third column. So I go down, second row, third column, I'll get 4. So, and remember it's, the third would be 2 because of 0 indexing. That gets really annoying, so that's why I'm kind of repeating it so you guys don't forget. So, okay, cool, it works. We get 4. Now, what if I wanted an entire row or an entire column? So, again, let's go back. We have the comma, we're separating the rows and the columns. Now, I want the first row. So I'll type in 0 where the row is, but I want everything from that row. So what I'll do is I'll go to where the column is and I'll put in a colon. So what this colon is essentially telling NumPy is that I want from the 0 index or the first row, I want every single data point. So I should expect an array of 3, 3, 4. And as you can see, that's what I get. And then you can mess around the second row, 2, 2, 4. And then the third row, 3, 32, and 4. Now, same thing goes for pulling out columns. So I want the 0 column, the first column, and then I want everything from that row. So I should expect 3, 2, 3. And then 1 would give me 3, 2, 32. And then the third column should give me all 4s. All right. So any questions with that? Okay, cool. Now we can go to Matplotlib and Pyplot. So Matplotlib is an excellent package for any type of visualization. You want to make a quick scatter plot, a quick bar plot, anything you want, you can do. And there are a bunch of default graphs given to you, or you can create your own as well from scratch, essentially. I'm just going to show you here just the different plots that you have from the get-go. I think I'll get into creating figures. Excuse me, I'll get into creating figures in the Matplotlib and Pyplot workshop on its own, because that can get pretty intensive, and there are little semantics that are pretty that can get pretty confusing. So here we'll call it a bit differently. So we want so Pyplot is essentially like a subclass of Matplotlib. So what we'll do is say from Matplotlib import Pyplot. Now here we would import NumPy. We wouldn't say from NumPy import random, for example. That's if we use from NumPy, then we have to call a subclass within it. So we would have to say from NumPy import array or import random. So anytime you have this dot, you're essentially going into a subclass within this larger class. So for Pyplot, we generally don't need everything from Matplotlib. You can just use Pyplot as is, and you can get a lot of work done. So we'll say from Matplotlib import Pyplot, and then as PLT. So Pyplot is PLT, and we'll run that. Now, if you remember, we have this normal that we saved up here. We have 100 points. The mean is 3, and the standard deviation is 1. Now let's say, again, you didn't create this, you were just given this variable. Okay. So let's look at this again. Now you have no idea what this is. You were just given this. This just looks like a bunch of data. So I can plot it. Let's first plot it. So we'll say plt.plot, let's say. This will give you a line. This will give you like essentially a line chart. And so you see it's kind of scattered. So, okay, cool. This is the index. So like the first data point is somewhere under 3. And if you look, let's look at normal. It's around 2.45. And as you can see, that's kind of where it is here. And it scatters. So now you're given this and you say, okay, well, this doesn't really tell me much. let me look at the distribution. So what I can do, instead of plt.plot, I can type in histogram. Now you see hist and hist2d. We just want to work with hist. Hist2d is, even though it says 2 dimensions, you're using 2 dimensions and comparing them within each other, but we just have one array. This isn't a matrix. This is just a very long row. So if I want to see the histogram of this, you'll see, hey, this looks relatively normal. And so this might give you a pretty good indication of, say, where your data from this variable came from, which we already know is from a normal distribution. And it peaks around 3, which looks good because, well, we had the mean set to 3. So that's pretty good. Now, what else can we do? Now, if we set plt dot and then hit tab, just give this a second. Oh, here we go. Okay, so you have all of this that you can do. So you have a bunch of different, you can do a box plot. You can create color maps. So you have all of this you can essentially use. Msave, or sorry, mread, mshow. That's if you have images, you can load those in as well. You can make it interactive. And so you have a bunch of different things. You can make a pie chart. You can plot, like I said before, plot is pretty simple. And you can see plot date here. We'll use that when we mess around with the avocado data set. This is really useful for time series. And so, yeah, we have a bunch of different things. You can even do scatter, and we'll go back to the normal. Whoops. Okay, so so let's look at this error. It says scatter is missing one required positional y. So with the scatter plot, you need an x and you need a y. So so these points, we'll consider this to be our y. Now the x would just be where it is. So this is 0, 1, 2, and so on. So what you can do is say, well, I want now if I look at the length, I have this. I have 100. Cool. If I say for I in range of, now if I set a for loop in the range of the length, I should expect 0 through 100. What I can do is I can actually put all of this in a list by saying, so I create a list. Let's say I'll call this index. I'll say I for I in range of the length of normal. So what this does is essentially says, I want to put I in this list for all the i's in the range of this. So essentially what we see here, I want to put all of this into a list. And so that's what I'll do here. And actually I'll make it a NumPy array. So we just put this list and we create an array out of it. And now we can say plt.scatter index, which is our x value, and normal, which is our y. And now as you can see, you have your indices here, and you have the value of those indices right around here. So any questions? Okay, cool. So that's pretty much it. You guys can start working on the exercises if you want, but other than that, I'm pretty much done. So yeah, if you have any questions, feel free to ask.
This was a great presentation.
Thank you, man. I appreciate it.
Mhm.
Yeah,
Thank you
thank
for
you, man.
showing us.
Let me stop sharing here. And we'll stop recording.